This is an introduction to exercise 9A on review of probability, page 566 of our textbook. So really question we're answering is, what are the key terminology we should recall from previous years? You've done probability in the past, and you've learned about these key terms, but I really just want to make it very clear so that when I ask you questions using this terminology, you understand what I'm looking for. So, the bolded words, as I mentioned, the bolded words are the ones that you need to get down as definitions. If you really want to copy it word for word, you can, but you don't need to. The first term we're looking at is random experiment. Okay, so random experiments, you know what random means? We just did an activity on that. Random means that there's an equal chance of whatever happening to happen. Okay, so random experiment results in a list of outcomes which occur without interference. For example, you're flipping a coin. Or let's say you're flipping two coins, yeah? An outcome could be heads, heads. It could be heads, tails. It could be tails, tails. Those are outcomes. Whereas the random experiment, of course, experiment has those outcomes. A sample space. Now, the key definition here that we need to know the difference between is sample space versus outcomes. So a sample space is the list of all possible outcomes, whereas an outcome is just something that can happen as a result. So for example, again, we're going to go back to the flipping two coins. Your outcome could be heads, heads. But your sample space is heads, 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 tails, tails, heads, and tails, tails. So again, your sample space is all possible outcomes. All possible outcomes. Are you happy for me to move on to the next dot point, or shall I give you a little bit of time to write that down? So you're writing down what you think is important for this section. So at this stage, I feel that random experiment... it's frozen. Random experiment results in a list of outcomes. That's important. And sample space is a list of all possible outcomes. I think those two are the most important components. Let me just underline what I think you should be writing down at a minimum. There we go. The next dot point is set brackets. You don't need to know the name. You just need to know their squiggly lines, right? Are used to list sets of numbers or other objects. So, for example, if I want to list 1, 2, 3, I would use squiggly brackets 1, 2, 3. Okay? Just be careful with your brackets so they don't just look like threes. Otherwise, your answer would be wrong. To write your squiggly brackets, you just draw something that looks like this. It'll take practice. It's a bit of a weird one. So, these brackets, that's all we're focusing on. An event is a collection of outcomes resulting from an experiment. Event, collection of outcomes. And then there's a formula. And then there's one definition, and I'm happy to move on from the notes there. Now, the probability is something that we're familiar with. It's the same probability we used for today's session, activity. It's also the same as what we did yesterday regarding our coin flip analogy. The probability of an event in which all outcomes are equally likely is a very important note there, right? We'll touch on that in a future lesson and in a future year, but for now, just keep that in mind. Equally likely is given by this formula here. I'd like you to copy this formula down. It is also in the first page of your booklet, so if you want to copy it down from there, you're welcome to do so. But really just says the probability, and the PR bracket means probability, by the way. So the probability of an event equals the number of outcomes divided by the total number of outcomes. The dot point under that, I'm going to talk through. You don't need to write down. At some stage, I would definitely recommend writing down in your resource book, maybe closer to an assessment, but that won't be this term, so don't stress about that at this stage. For all events, 0 is less than probability event, which is less than 1. What does that mean? What it means is we're very used to talking in percentages. So for example, the percentage of rain tomorrow is 60%. Right? But 60%, as you remember from your conversion, is 0.6. Probability should only be between 0 and 1. Now, if you look at the scale, you'll see that 0 means, of course, no chance at all, and 1 means certain chance, which means it's definitely going to happen. So, for example, if I said, what's the probability, in decimal form, that the sun rises tomorrow? What would the probability be? 1. You could argue 1. Now, technically speaking, you could also argue that what if, the sun just disappears? It's possible because etc, etc. Maybe it's 0.99999. If I said, for example, what's the probability that I turn into a butterfly right now? You'd say 0. So, depending on what the probability is, you use the words. So, for example, if it's 0.7, I'd say it's a pretty high chance. You just follow through the scale. But of course 0.5 being in the middle because that's 50-50. Last thing I need you to write down for this component is this term right here, complement. So complement is the event in which A does not occur. I should probably write of an event A as well. So complement event A is the event in which A does not occur. This is a term that you've learned in previous years. I'll take by the blank stares, that's a no. Complement just means opposite. Really just means opposite. So for example, if I had, let's say, I wanted to look for the probability of getting a 1 on the dice. The complement of getting a 1 on the dice is to get a 2, 3, 4, or 5, or 6. Just anything else. That's just the opposite. Now the formula is right there. The probability of not A, which is what complement is 1 minus probability of A. Remembering that 1 is everything. That's 100%. 1 is everything. And if you get rid of the probability of A, that'll give you the probability of not A, or the complement. I know there's quite a bit of terms to write down, but future lessons won't have this many words. Alright, let's move on to the next section. It's an example. I don't need you to write it down because you're going to be doing some practice questions in this anyway. The spinner has 8 equally divided sections. List the sample space using the given numbers. So the sample space, remembering that it says up here, the sample space is the list of all possible outcomes. So my sample space, and I want to use the squiggly brackets or the set brackets to demonstrate my answer. It's going to be, let's try that again. It's going to be 1, 2, 3, 4, and 5. And then I close my bracket. Note that even though there are 3 2's, I didn't write 2, 2, 2. Yes? How long has it been frozen for? Okay, I'll reconnect it now. Alright, let's try that again. So, as I mentioned before, even though there are multiple 2's on the spinner, the sample space is just going to be 2. Right? So 1, 2, 3, 4, 5, and I'm going to use the squiggly brackets. The probability of 2 itself, right, and I'm going to use the formula from above, which says the number of outcomes, which I know there are 3 2's, so I'm going to write 3 over the total number, which I know there are 8 total sectors, so 3 over 8. That's it. The probability of a not 2 would be the same probability of anything other than 2, right? So there's a 4, a 5, 3, a 1, and a 5. So there's actually 5 options that are not 2. So in other words, 5 over 8. Again, reminder, a complement is 1 minus that. So I could have said 1 minus 3 over 8 would give me the same answer. The probability of a 2 or a 5, that's going to be 1, 2, 3, 4, 5 options. So that's going to be 5 out of a total of 8 as well. Find the probability the number is at least 2. So again, I'm going to circle the ones that are valid. So at least 2. These are all at least 2, because 2 is also at least 2, of course. So the probability of that would be 7 out of 8. That's it. Relatively straightforward. Okay. Just make sure you have the terms written down as well. How long was that